Okay, so in this question, based on the word tangent, and there is a curve, and you want to find out whether the tangent passes through this point. Alright, so because of the word tangent, most of you will know by now, oh, it's a topic on differentiation. You will do your dy dx. Okay, but that's the only thing I know what to do. So I need to visualize how it looks like. But I don't know how the curve looks like. Never mind. I just anyhow draw a curve. Okay? So we ask whether the point 1, 4 lies on the curve. Okay? So Wei Hang say no. Then Luffy justify. Very simple. Check. Sub the point number 1 inside the curve. You realize the value of y when you sub x is equal to 1 is actually y equal to half. Since y equal to half, this is not equal to 4. So we all agree 1, 4 do not lie on the curve. Alright? So I'm going to draw 1, 4 outside. But we want to check whether the tangent line cuts through. So I just assume it cuts through first. So I draw a tangent line. It cuts through. Okay? Now, so the gray line that I just drawn up is the tangent line. And you all told me I can find the gradient of the tangent line by substituting x is equal to 1. Am I right? So, okay, I'm going to do that. So, dy dx, of course, when x is equal to 1, okay, I'll substitute inside, so you get 1 over 2 square, which is 1/4. Am I right? This means that the gradient here is 1/4. Okay, let me write down. But these are all the things I know. There could be another tangent line, I'm not sure, but our job is to find out. But they want you to determine the coordinates of the point on the curve. So if I really want to determine, I think all of us will agree, oh, I need to find out this coordinate that I just marked out in red color. So if I really want to find the coordinates of the red point on the curve, and I also, like we all agree, finding gradient of a straight line is not just dy dx. The other useful formula, which you just told me, y1 minus y2, x1 minus x2. Okay, now comes the very important thing. In order for me to use this particular gradient that we learned last year, I need to know the coordinates of the red point over here. But teacher, I really don't know. Yes, I also don't know. Okay, I need to make some assumption, or rather, I substitute. All agree the red point will lie on the curve? Okay, I'm going to use an easy method. Don't use x and y, very confusing. Let me use another letter. Let me use A. If my value of x is A, can you tell me what will be the y coordinates? I substitute and replace my x by A. Am I right? A over A plus 1. Thank you, Deepak. Wow, very smart. So see, now that we have 2 points, and we clearly know these 2 points lie on the tangent line, and the gradient must be equal to 1/4. Using the straight line gradient method to find the gradient, that's what I'm going to do next. So as you told me, the gradient is equal to 1/4. Now our job very simple. Cross multiply, simplify, solve for it. Alright? Okay, so basically, you just need to solve for the quadratic equation in A. After you found your A, straight away press the calculator, find the value of A over A plus 1, which will give you your x and y coordinate respectively. Since there are 2 sets of answer, there are 2 tangents, and you write down the 2 pairs of coordinates correspondingly.